At this very moment, every atom in your body is orbiting a black hole, not metaphorically, not someday, now. 4 million times the mass of our sun, compressed into a region smaller than our solar system, it lurks at the center of the Milky Way, invisible, patient, and in absolute control. We call it Sagittarius A star. But that name belies its true nature. It is not some distant curiosity. It is the force that owns us. On a clear night, gaze up at the Milky Way, and you will see a river of light, billions of ancient, magnificent stars stretching across the sky. But that river has a drain, and it is not what you expect. At the very heart of our galaxy, hidden behind dense clouds of cosmic dust spanning hundreds of light years, there is no radiant core, no glowing heart, only a shadow, a scar in the fabric of space-time, 4 million times the mass of our sun. Sagittarius, a star, is a supermassive black hole, compressed into a region of space so small that physics itself has no language to describe what lies within. Yet what it does to everything outside, we understand perfectly. Every star you see from Earth is gravitationally bound to Sagittarius A star, every planet, every moon. The entire 4 billion-year history of life on this world exists only because the orbits are stable enough and the monster is patient enough to allow it. We are not mere neighbors to something dangerous. We are in orbit around it. And that difference is everything. For most of its existence, Sagittarius A star has been eerily quiet. Unlike the violent quasars that ravaged the early universe, consuming entire star systems in catastrophic feeding frenzies, our black hole feeds on almost nothing. Scattered gas drifting through the galactic center, cosmic dust, the remnants of dead stars slowly dissolving into its gravitational field. A sleeping giant, starving in the dark. But do not mistake this silence for safety, for when a wandering star strays too close, the giant does not stay asleep. The moment a star crosses the tidal radius of Sagittarius A star, physics becomes merciless. The gravitational pull on the star's near side becomes exponentially stronger than on its far side. The star does not fall in whole, it is stretched, torn apart. The forces are so extreme that the star's material is stretched into a long, blistering ribbon of plasma, thousands of degrees hot, accelerating toward the black hole at a fraction of light speed. Atom by atom, this process has a name: spaghettification. And it is every bit as brutal as it sounds. A star that has burned for billions of years, forged in the galaxy's first moments, reduced in weeks to a glowing thread of superheated gas, spiraling inward to feed a hunger that can never be sated. That infalling material does not vanish immediately. It forms an accretion disk, a churning maelstrom of superheated plasma, spinning at a fraction of light speed, heated by violent turbulence and magnetic forces to millions of degrees. In more active galaxies, these disks outshine the combined light of hundreds of billions of stars, entire galaxies, in fact. Yet at the heart of that blinding inferno lies something that emits no light at all: the event horizon. This is not a surface, not a wall. It is a threshold, invisible, absolute, where escape velocity exceeds even the speed of light. Cross it, and you are no longer part of the observable universe, not trapped, simply erased from it, permanently and completely. Nothing escapes, not radiation, not information, not light. Here is where physics becomes truly vertiginous. If you could watch a star cross the event horizon, you would never see it arrive. The immense gravity warps time so severely that, from your perspective, the star's image would freeze at the edge, slowly fading into a deep, ghostly red as time itself grinds to a halt. Yet for the star, there is no pause. Its descent is relentless. Dragged toward what Einstein's equations predict, a singularity, a point of infinite density where the mathematics of general relativity simply breaks down. Not because the universe stops, but because our ability to describe it fails. We live our brief lives in the quiet suburbs of the Milky Way, 26,000 light-years from the center, and we feel none of this directly. Yet we are held by it every second of every day. Tonight, somewhere, someone will gaze up at the Milky Way and feel nothing unusual. But 26,000 light-years away, something watches them in return. Patient, still, unchanging. It has always been there, and it will remain long after the last star in the universe burns out and dies. Long after the galaxies go dark. Long after everything we have ever called real dissolves into cold silence. We are not orbiting a monster. We belong to it.